Alright, welcome back to your regularly scheduled programming lectures. Let's get through this arrays slide, some more arrays and vectors. We're going to start talking about them too today, the magical things called vectors. So yeah, let's just remember first what arrays are all about. They are essentially a variable with one name, but you get a bunch of stuff that you can put inside of it. Alright, and they all have to be the same type. So you can say something like this: int, give it a name r, and then you don't have to put any numbers in here if you immediately give all the values in that array. Like 1, 2, 3, then it's implicitly an array of size 3, and that creates in memory something that looks like this. So it's called R. It's got one name, but it's got 3 slots. Accessible indices 0, 1, 2, and holding these values, right? 1, 2, and 3. So that's what R looks like, and the size is very, very important. Arrays get a specific size. You cannot change it. You're either going to say it explicitly or implicitly. Here it was implicit. You gave 3 things, so it made a size 3 array. But you could have said 3 there, 42 here. The rest would have just been garbage or something. That's how it works. Right? You cannot change it later, and you can't go to a bad index. Right? Don't just pretend that this index 3 exists. It's not going to work. All right? That's how that works. And yeah, just like for strings, you can get at each index and set them individually. Just the syntax is a little bit different. It's going to be R and then use the brackets like that. Go to index I and set it to, I don't know, 1 more than it was. Something like that. And you can also use that same syntax, though, to get the value, just like you were getting it here. Just like maybe you want to print the value at a certain index. R of j, who knows? So those are the kinds of things you can do with an array. It's very useful, but remember it's all ints. It's not like some ints, some other things. It's all one type, okay? Yeah, I think the first thing I want to show you in code today is multi-dimensional arrays. This is a cool idea, all right? Because sometimes you need more than one index to do cool stuff, all right? So for example, say you have an image, right? Images are grids of pixels, right? If you zoom in really closely on any screen, right, or any picture, eventually you'll see little squares, right? I guess it's trying to make it pretty when I zoom in on my windows. I think I can turn that off though. But take a magnifying glass to a screen or to a digital image, you will see each pixel. It's just a single color. It's a grid of colors, all right? And so if you want to talk about like which colors what, if you're going to store this inside of a computer, an image, you want to be accessing like, I want to know that like row 2, column 1 of the image is set to the color 42 or something. Like that's what you need to be able to do. And that is possible with multi-dimensional arrays. You'll get 2 indices out of the deal if you have a 2D array, for example. So that would look like this. Let's pretend that images are made up of numbers, just a bunch of numbers per pixel, and that's technically correct. So here's kind of how you would have declared this array. You say it like this, all right? So it's int, let's call it R again, and then it's going to be 3 by 3, give it twice like that. Does that make sense? So it's going to make a 3 by 3 array of vectors with really 9 elements. So you get 2 indices. You could have made a 3D array if you wanted to, okay? But yeah, if you have multiple indices, that makes it multi-dimensional. And say I want to access this one. I want to go to row 2, column 1 of the array and set it to the color represented by the number 42. I'd say this, R of 2, 1. That's supposed to be the number 1. 2, 1 equals 42. Okay, so that's how that works. It's just a little bit of extra syntax. It hopefully makes sense. But say you've been given an array that looks like this. It's declared like this, R of 42, 84. You get 42 times 84 indices. Do you know which ones you get, though? Let's look at all the directions, right? So you can go, of course, you get R0, 0, and then like you get R0, 1, all the way down to, in the first axis, right, R0, what's the last one here? 83, right? 83. And then along the other axis, you can go all the way to, for this first indexing, it can go up to 41. See that? It's always one less. I can go up to R of 41. And then 83 could be the last one there. So that's what you got to do when you're accessing things. Let's see. Let's make an example. Multi-dimensional. And I think I can zoom in a little bit more. There we go. So let's do that. Let's make this kind of array. Multi-dimensional array of ints. Int, call it R, and it's going to be, let's say, a 3 by 4 array, so it's a little bit different. Okay, and then you can set pieces of it, like r at first index 2, second index 1, that's valid, right? Set it to 42, and then you can, of course, use that later. R of 2, 1, give me that back, please. So that's a multi-dimensional array. Cool, and of course I get the 42 back. But you can do this with an array of chars, an array of strings, whatever you want to put in here inside this array. You can have 2 dimensions, 3 dimensions. Let's just think about it. The world is your oyster. So that's kind of neat. That's multi-dimensional stuff. Let's now talk about bad things about arrays. I guess I told you one already, right? This sort of undefined behavior. You can just access stuff and it might work, which is disgusting. So we know that. Let's just write it all down, what we know. All right. So the first bad thing about arrays is you have to say how big it is up front, and it can never change. So you're stuck with a given size. All right. And then also, the array doesn't even know its size. Case in point, right? You can go outside of it, and it's not ever going to complain. It has no clue what its real size is. You have to remember that yourself. All right. So in general, you have to like make a size variable to just remind yourself how big your array is every time you make one. Okay. Or just hard code it in some way. And yeah, that gives you the ability, right, to access past the end of it and not know it and get really weird bugs just in case that memory that you really mess with was still yours. All right, that might not always be the case. So yeah, that's disgusting. But yeah, that's kind of something like this, right? Say you made this array with indices, if I get them right, indices up to 3, right? 4 things, so indices 0, 1, 2, and 3 for this array. You can totally try to access index 4 even though it doesn't exist, and sometimes it will work. It will just mess with some other memory that's yours, okay? So that's unfortunate. Those are some bad things about arrays, and I promised you that there's something cooler than arrays called vectors that are just better. Better in general, you want to use them when you can. So we can solve all these problems with this cool new idea called vectors, and I will get to that in just one more slide. So the last thing I want to talk about, this will be applicable to everything, both arrays and for vectors, so let's talk about it now. You're going to want to swap 2 places, two elements in an array with each other, and so let's talk about the algorithm to do that. We're going to notice that the naive way to maybe want to go and do that is wrong. So it's worth having a slide on this. Let's say that we've got this array. It holds 1, 2, 3 at indices 0, 1, and 2. And let's say that I don't like the order. I want to make it like reverse order. So I want to swap the thing at index 0 with the thing at index 2, turning it into, instead of 1, 2, 3, 3, 2, 1. That's what I'd like to do. The naive way of doing that, the way that you would imagine would work, is actually not going to work. You'd say, like, here's what you might think would work. Like, all right, I want to put at r of 0 the thing in r of 2, right? Bam. And I want to put at r of 2 the thing in r of 0, right? R of 2 equals r of 0. But this will not work. All right, let me show that to you. Let me draw it. Do you see it? Can you run it in your mind and see the problem there? So here, let me draw a sample version of that array over here. 0, 1, 2, holding 1, 2, 3. And so let's run through these 2 lines. So r of 0 equals r of 2. So that's going to shove whatever's in r of 2 into r of 0, right? So whatever's here is going right here. So the 3, we're putting a 3 right here. See that? That's what that first line does. Now the second line comes along and it's like, all right, r of 2, I'm going to set this to whatever is at this index. I'm going to move that into here. So do you see how that's just going to like put 3 there because it's already 3? Do you see the problem? We just lost the 1. That's not good. So the right way to do it is before you lose that 1, you better save it somewhere. All right, you better save what you're about to overwrite, otherwise it's gone forever. Okay, so you actually need an extra helper variable. So here's the secret. You need like a let me walk you through it before I write the code. Here's what you must do. All right, 1, 2, 3. Before you lose that 1, you better save it safely somewhere. Let's make like a temp variable. Save it there. All right, because then you can do everything else. You can swap, place the thing at index 2 in there, and then like you still got it in temp, and you can place it in the right spot. All right, so like that's what we want, and here's the code for that. You say this: int temp equals, and this could be any name, of course, equals r of 0, and then you can then go and get rid of the thing at r of 0. You can replace it. Equals your r of 2, and then that does not look like a 0, does it? Here, let me fix that. It looks like a backwards lowercase Greek sigma. There we go. And then you go and you can say r of 2 equals temp now. You've saved away safely that thing. So that's what's going to work. That's the magic. And so let me box that with rainbow. All right, and let me draw you exactly how that's going to work, and we'll see that it correctly swaps things. All right, so it's worth having a slide on this stuff. So the very first thing you do is save the thing you're about to overwrite on the next line. So all right, r of 0, save it safely in temp. So I'll put a 1 there. All right, then you can run this line, and everything's okay. It's going to replace r of 0 with whatever is at r of 2. So this guy's coming into here. So we get a 3 there for that with that line, and then we say r of 2 equals temp, and do you see how we have the 1 still? So I'm shoving that into r of 2. And that's going to do the right thing. All right, so you needed a helper variable to get the job done. And so this is the syntax. There is a pattern that will help you memorize it. Though just like think about it, that will help as well. But like here's the pattern. The very first thing you do is set the temp variable. And then it's always the last thing on, like the thing you set into on the last line becomes the thing you're messing with. The thing you saved on the last line becomes the thing you mess with on the next line after it. Okay? So previous line, this thing, becomes first line, this thing. All right, see how they correspond? And then the R2s correspond, like you're just saving it, and then you're messing with it. All right, and then like the temps kind of wrap back around. That's how you can remember it. That's how I do it, at least. So, yeah, that's how you swap things, and that's going to be very necessary. For example, if you want to make an algorithm that sorts an array, you'll need to like move things because it might be jumbled, right? So swapping is going to be very, very important. So it's good to know how to do it. And now I think I'm ready to talk about vectors. Are you ready? Let's do it. So let's talk about vectors. It is it's a type just like string. It's part of a library. It's not baked into C++. We have to include the library. Right? It's something called the vector library, which you can search for. Follow this link, or I'm already kind of on the place, right? So let's go to. It's in the containers section. So here's vector, and here's the vector type. You click on it. You scroll down, you learn cool stuff about it, but let's see. I'll just click on a link and it'll show me a little example of a vector. So this is kind of what a vector looks like. You say something like this, then you can access pieces of it. I'll show you how, okay? But yeah, this page, you'll want to stare at it because it shows you all the things you can do to a vector. I'm going to explain a few of those today. All right, so very similar to strings in the sense that instead of going to indices like this, like we did for arrays, we get the .add again. We get the .add again, and it will yell at us if we go outside the end of a vector. That's perfect. That's what we need. All right, that's going to save our lives in this class. So vectors are similar to strings in that regard, but you can store any type. All right. So yeah, vector is a C++'s name for what's called a dynamic array. All right, that's the real name that everybody's agreed on that this thing is. And dynamic means it can change. That's very interesting. So it's also like a string in that regard, because strings can change their size. So a vector size can grow. It can grow. There's an operation called .pushback. That's really, really neat. All right. So let me show that to you. You can make a vector, which looks like an array for all intents and purposes, but it can grow. It's a dynamic array. All right. So let's say you got this guy. You can come along and say .pushback to this vector. You can say like v dot push back, push underscore back. Like you're pushing it on to the end of it, push to the back, right? With a value. And what this will do is it will add to the end, right? This adds a new element to the end of the vector. That's much better than arrays already, right? Adds a new element to the end. And so like when you run that line, what it will do is this. Like you run this line, it creates in index 3, whatever is at the end. It makes one more after it, and it puts the value you asked for there. That's amazing. That's great. All right. So that's one really nice thing about vectors. It solves one of the issues with arrays, right? It'll solve all these issues, actually. If you try to go to a weird place, remember to use the .at operation to get to a place in a vector. you're going to get a runtime error. It will stop your program and complain rather than just like setting some random memory and you getting a really weird error later. Okay? So yeah, instead of this syntax does work for vectors, but please don't use it. Please don't use it. Always use the .at for vectors. So it becomes this, v.at, whatever index. Okay? That's what that turns into. Yeah, vectors also know their current size. Like there's a .size operation that you could use. And so you say v.size on your vector, whatever it is right now, like that one, and then it will give you back how many elements it has, which is 4 right now. And if it grows, .size will tell you its new size later. Okay? That's so nice, right? Vectors are so much better than arrays, but they're kind of like a wrapper around arrays secretly. So that's why you need to learn about the base idea first, right? But now just use vectors for the rest of your life if you can. So yeah, I've got 2 ideas for a demo. Let's go over some code where we make a vector hold 1, 2, 3, and so we can see like the difference in the syntax, because it is a little bit different to just normal arrays. So it's part of a library, first of all. Arrays are baked into the language, just like ints and stuff. There's nothing you need to include to get arrays, but to make a vector, you do have to include the vector library. All right. So if I want vectors, I need to say include vector. That's its name. All right. And so instead of this, to make an array, we do it like this with 1, 2, 3, right? In vector land, this is what it would look like. All right, I want to make a vector hold 1, 2, 3. Kind of the equivalent of this syntax is the following. You say vector int between angle brackets, just like the static cast, remember that? V equals 1, 2, 3. So that's the new syntax. All right. I hope that makes sense. So like the type is all in one place, which I like better, honestly, because like this is a little backwards for arrays. Like you read it like this: R is an array of ints, whereas you can see immediately this is a vector that holds ints inside of it, called V, and here's the things inside of it. That's kind of nice, right? And so to get the values, it's V at the indices, right? V at 0, V at 1, V at 2. I could have done a loop, but I'm lazy. And that'll print my 1, 2, 3. So that's one way to do it. But you also know that you could use the pushback. You can do the following. The following makes sense for vectors, but definitely not for arrays. You can say this: vector of ints, call it v2 semicolon. See how this makes absolutely no sense for arrays, because I never set a size anywhere. You can have empty vectors to start in C++. It's beautiful. v2 is an empty right now. Vector of ints, and that's fine because it can grow. It can grow with the dot pushback. That's the greatest operation ever. So I can say v2 dot add to the end of it, add to the end of your nothing right now. So that gives it the first thing inside of it. Holds a 1 now, add a 2 to the end of that, add a 3 to the end of that. Do you see how that's going to build up? 1, 2, 3. All right. And here, let's put all these on the same line so I can show you both. There. And so let's do the same to print out v2. So I'll say right here, v2 dot add all those places. And so they're both 1, 2, 3s. Okay? Isn't that neat? That's really cool, I think. All right? So that's my first demo. Let's also have a demo where we get just a bunch of elements from the user and put them all into a vector, and we don't need to know ahead of time how many, because we can just like keep going, keep doing dot pushback until either we run out of memory and the program crashes, or let's say the user types -1 when they're done. We're going to use -1 to mean I'm done typing. That wasn't a real number I wanted you to put in the vector. Okay, so let's do that. Let's fill in a third vector of ints, I guess. Vector of int v3. You could totally have vectors of doubles and chars, so I'm just going to use ints as an example here. So an empty vector v3, and I'm just going to have an infinite loop until the user's done typing. Until they type -1 to mean I'm done, I want to put whatever number the user gives me, other than -1, into v3. Okay, so I'll say, let's see, let's give them a prompt. Enter a number to add to v3, or -1 to quit. All right, and so then I'll get a number, int n, cn, int n. And then like, all right, if n was -1, I'm done. So I'll break out of my loop and not actually add that to the vector. But if I'm still here, right, if I'm still down here, that was a good number. It wasn't -1 and I want to add it. So I'll say v3.pushback that number n that I just got. Okay? I hope that makes sense. So yeah, that's just going to fill a vector with whatever the user gives me. and we should print it out now, right? So let's go and loop through. Let's iterate through v3 and visit every index that we see. All right. And so here's the trick, because vectors know their size. You're going to say for int I equals 0. That's your first index, right? And you want to keep going while I is strictly smaller than the size, right? v3.size. And that's where it knows its size. It'll give you back its size right there, v3.size, however big it is. If it's 5 elements, it'll give you back 5. And that's perfect, because you want your I to go up to 4, strictly smaller, I++. And then we can say cout v3 at I, and then let's space separate them like I was doing above. And then a new line after it's done to break the line. So that's a pretty cool use case, I think. Here, let's do it like this. I think I can show it to you. So there's the code, getting stuff, filling it in, and then print it back out. Okay? Let's compile. Let's run. And so I'll just like do some numbers, 8, 6, 7, 5, 3, 0, 9. And then when I'm done, I can say -1. And then I'll stop the loop, break out of the loop, and now I'm down here. I'll go through with however many things I put into the array. And that was apparently 7 things. So I went up to index 6, right? And that's printing them all out. That's pretty neat. I like it. All right, so that's vectors in a nutshell. And yeah, so let's talk about iteration. All right, just remember that word just means going through something. So we just iterated through this vector. Okay, we iterated through v3. We visited every index that was there, and this is kind of the standard way that you'd use for arrays and for vectors. Just like start your index at 0, go until it's less than the size, I++. So you can do it that way. That will always work if you need the control. But there's actually a cool new way that was invented as part of the 2011 version of C++. So it's not super new anymore, but a lot of people like it. You can only do this for vectors. All right, what I'm about to show you will only work for vectors, not for arrays. If you want to go through a vector in order from left to right, you can type less than this. All right, here's the secret. So let's say you got this vector v, and it holds the following. Let's say it has 3 things in it. My favorite, 1, 2, 3. So here is a new thing. It's called a range-based for loop. All right, so instead of going through every element of the array this way, like using the .at, you can do this. You can say for. Then in parentheses you say int, and then give a name, like I'll call it elem. You could name that anything though. And then you put a colon, and then you put the thing you're going through, so v. And then you have your body, all right? And then you use this variable here called elem, whatever you made. It could have been x, whatever you want it to be called, and you can use it, all right? So maybe I'll like cout it with some spaces. Maybe that's how I want to use elem. So what this loop does, is it goes through v in order. You read it like this. It says, you kind of read it like this. For every integer element in v, you read the colon as in. And it'll just go through v and let elem have a chance at being all of the elements in order from left to right. That's pretty neat, right? So this will run the body in this way. It'll create this variable elem just for the life of the for loop. You could have called this anything else. Could have called it x or y. Doesn't matter. And it will get a chance at being all the values in the array. So the very first thing elem gets to be is 1, and then it runs the body, and it'll print the 1. And then it'll just keep resetting it as long as there's other things. Like it'll just like keep going. Now it'll set 2 into elem. And then run the body with elem set to 2. It just goes through, ranges through all the values that is in the vector. And then the last one will be 3. So it runs the body with elem set to 3, and then like that's the last thing, so it's done with the loop. Okay? So that's called a range-based for loop. It's pretty neat. For every int element in v. Okay? That's how you read it. That's pretty cool. Let's have an example of that. So let's see, let's include the vector library, of course. And let's make, this time, let's make a vector of doubles, right? Why not? So let's have it hold like 1.5, 2.75, 3.14. Beautiful. And then we'll say for int I equals 0. This is the old way, right, to iterate through it. I is less than, oh, so, excuse me, I need to give it a name, don't I? Call it v. Call it v. There we go. And then here's how you iterate through it. You start at index 0, go until it's less than the size, right? v.size, I++. That's a very valid way to do it. And it's going to work always. Cout v at I. And let's do like some spaces. So that's the way you know and love right now. But you could also have used, for vectors, the range-based for loop. All right, so there it is printing out the elements. So instead of this, I will turn this into a range-based for loop, and it's going to essentially be the same code. It will give me the same effect. So here's that. You say for every type name, right? It's a double now. For every double element, I'll call it elem in the vector v. So you give it like that, and then you say what you want to do with each element in order. So I want to take elem and print it out with a space. Oops. And then a new line. And so both of those will do the exact same thing. If you just want to go from left to right, this is less typing. All right, you have more fine-grained control with the indices. That you can go backwards very easily. You can go by twos if you want to just visit every even index for some reason. Like, that's possible. Okay, so you can't get that with a range-based for loop, but a lot of the time we just want to go from left to right, and so that's shorthand for it. All right, so yeah, I think the last major topic that I want to show you today is sorting. All right, so this is just something that's been done for you. Eventually, you'll learn sorting algorithms, like how to do your own sorting stuff, but there is a library called algorithm, and inside of it, there's just a sort function pre-made that you can use. It's pretty nice. So let's go look at that. It's in the algorithm library, also called header. I'll say the word header later, and you'll understand it, all right? But it's in other. It's the algorithm header file, essentially, but I'll call it library too. And so there's a bunch of cool functions in this library, one of which is sort. It's just called sort. And this all looks really weird. Like, what is a random access iterator? I have no clue. But that's okay. I will teach you how to use this. All right, it looks a little weird. Actually, this is a much better example, I guess. This is how you would use it for a vector if you want to sort pieces of it. You can also use it for arrays. But yeah, I think it's better for just me to show you exactly what's going on, because the syntax looks a little weird. So here. It's one of those things you got to memorize before I teach you what's really going on under the hood. But the sort function, what you do is you give it two things, all right? You give to the sort function the beginning of the place in memory that you want to sort, and the ending location also of the place in memory that you want to sort. So you want to say, I want to sort between some start point and some end point in memory. All right, so that's what's going to happen. You're going to say sort, and you give it the starting location memory of like your vector or array, like where does it begin, and then you give it the end of your vector or array, and like it knows to sort up till there, all those elements up till there. It's actually one past the end, all right? So that's the first weird thing. So you give it the starting location of memory, and then you give it one past the end. Like, don't go all the way up to there. That's past the last element. One past the end. And that's how you call sort, all right? I'll show you like how to actually give those values, how to give those places in memory in a second. But yeah, what sort is going to do is it's going to sort from the start location inclusive, right? I hope you've seen that syntax before in like a math class. It'll sort from start inclusive to end exclusive. All right, so that's why you give it one past the end. All right, that's how it works. And here is how you call it. All right, to sort a vector, there are two operations called begin and end, dot begin and dot end, that give back the right things that sort once. So you give to sort v dot begin, that's the beginning location in memory, and v dot end is one past the end location in memory. It'll do it. It'll work perfectly. All right, so that's how sort works for vectors. For arrays, it looks really weird. So for arrays, you say, I want to sort, and then you give just the name of the array by itself. That is, for some reason, which I will teach to you later, the starting location in memory. And then to calculate the ending location, one past the end location, you can add to the name of your array. You say r plus its size. All right. I do not want to get into right now why this works and why that is giving you memory, but I can explain it offline if you'd like. So yeah, that's just how you do it. It's the thing to memorize right now. It's very useful. Sorting is very, very useful. So here's that. So if I want to sort a vector, I better include vector. And the sort function lives in the algorithm library. Algorithm. So for the sort function. Okay. And so here, let's make an array and a vector that's all jumbled. So int array equals 8, 6, 7, 5, 309. And then let's do the same for a vector. I'll make a vector of ints, call it v, and have it hold the same exact thing, okay? And then here's how you sort them. You say, if you want to sort the array, you say sort, give its name, and you say its name plus its size, which is 7 here, okay? That's a little weird, but that's how you do it for the arrays. And then for vectors, it looks slightly better, right? You say sort, and then you say v.begin, like that. It just knows where it lives in memory. And then v.end, that'll give you one past the end, okay? And so after these lines have been done, like it has shuffled around the elements of these places, of these things, and we can go and inspect and make sure it's sorted now. So to go through an array, you are stuck using indices. There's no range-based for loop for you. You got to use indices. I is less than 7, I plus plus, and you got to remember the size yourself. That's arrays for you. So that's me printing out the array. And then for vectors, let's be shorthand. Like for every int e in v, go through that vector, please. Call every element e in order, and I just want to see out e in a space. And then a new line right after that. Beautiful. Okay, so that's pretty much it. So here is here, maybe I can do it this way so you can see it all. Let's compile and run. There you go. Beautiful. And yeah, we're off to the races. It has sorted both of the values in both the array and the vector. It's beautiful, and this is just useful stuff, right? You're definitely going to want to sort something one day. So now you know how. Okay, now to finish us off for the lecture today, I would like to ask you a question. All right, I'd like you to pause the video and ponder this after I explain it. But let's say that we have a vector, all right? It's called v. We have no clue how big it is. Maybe we got the values from the user, so we have no guarantees about how big the vector is right now. And it doesn't have to have anything in order. Like, say that this is our vector v. It's got like, I don't know, 1, 4, 3, 2 at those indices, right? What I'd like you to think about is try to come up with on your own, just in words, an algorithm to reverse the contents of the vector. So like whatever you do, is there a way, can you think of how to do this, right? To turn this array into, like, keep it in itself though, just swap around or maneuver elements around. I think I accidentally gave you a hint there. Maneuver the elements around into, instead of 1, 4, 3, 2, just like 2, 3, 4, 1. Do you see it? That's what I want you to do at those same indices now. Like I want you to change this into this. Can you see kind of how you might do it? All right? And remember, as you're thinking about it, that your code should work regardless of the size of the vector. That's supposed to be size there, okay? The size of the vector, and like you'll need to use v.size and not just like, oh, it's always size 4, it's always size 5, okay? So think about that, and I'll come back and show you my ideas. So I think I accidentally gave away the secret because I said the word. It's going to involve swapping. All right, so that's going to reverse the array for you. Do you kind of see what you might do with this one? Just like if you were given this exact vector, you don't care if it's in order or not, you're just changing where the elements are. Just like if it's 1, 4, 3, 2, you're kind of going to like draw a post in the middle and do this kind of swap, right? You want to swap the 1 with the 2 and the 4 with the 3. Do you see how if you did that, it would turn into 2, 1 like that, and then 3, 4 like that, which is exactly what you wanted. That should work, all right? There is something that you're going to run into, though, because this is an even-sized array, right? What happens with that same idea with an odd-sized array or vector? Let's say it's size 5. Like somehow I want to turn that into this. 3, 5, 7, 6, 8, right? You can play the same game, but there's no like post in the middle. Like this, there's an element in the middle instead this time, which is a little weird. So what do you got to do? So you got to swap those guys, right? And swap these guys, and then like, how do you play the game with the 7? Like, do you swap it with itself? That doesn't actually make any sense, right? So you can kind of just not do anything for that middle element, but you have to remember that, right? That's going to be part of the algorithm. You know to stop, right? You stop there. So that that will give you what you want. You see how the 7 just kind of stays still. It's in the same spot. For an odd-sized array, that's going to be different for even and odd-sized arrays. All right, so let's come up with the full algorithm now. I'll talk you through it, and then we'll implement it next time. I just want you to think about it and maybe try it yourself before then, okay? So let's think about this, all right? So I know that it works differently for odd versus even arrays. Let's draw an example of an even array and an odd array. So let's say this is 1, 2, 3, 4, at indices 0, 1, 2, and 3, and let's say, let's have another example so we can make sure what we're about to do is going to work for it too. This will hold an odd number of values at an odd number of indices, okay? So let's think about this, all right? So what do we need to do? Like, this is kind of what's happening, right? We're doing this guy, swapping these. Like, what do you need to swap first is kind of the question. Like, you're going to do the same thing for this one, right? You're swapping these, and like, do you want to swap these? Not really, right? You just skip that one. So let's try to write that down, okay? So we need to do the following. We need to swap what? We need to swap the following indices, right? It's always going to be the first index, 0. Swap index 0 with the last index. Do you know how to get the last index out of a vector? Remember that? Let's see here. We need to swap index 0 with size minus 1, right? That's always going to give you the last index. v.size minus 1. And that will always do this part, right? It'll swap those guys. And then you want to swap index 1, right? The next one in with the one over, right? You just move your way inwards. So swap 1 and index not v.size minus 1, but minus 2. You see that? You just like keep following that pattern, okay? And now the question is, how many times do you play this game? How many swaps do you do? All right. You might think that you need to do 4 swaps for a size 4 vector. That is unfortunately not going to work. Let me show that to you. So let's say that would imply that you do like, all right, next it's swap index 2 and size minus, right? v.size minus 3. And then it would be swap index 3 with v.size minus 4. So you might think that you want to do 4 swaps for a size 4 vector, but look at the problem if you do that. So if you started with 1, 2, 3, 4, and you played this game 4 times, it wouldn't quite work. So let's swap 0 and size minus 1, that's these guys. So if we swap those, it becomes 4 here, 1 here. And if we swap index 1 and size minus 2, so that's index 1 and then 4 minus 2 is 2, swapping those guys. So I'll swap the 2 and the 3 to make 3 and 2. See how that's the right amount? If you went further, watch what happens. Swapping index 2 and size minus 3, so 4 minus 3 is 1. Watch what it's going to do. All right, now that's going to be 2, 3 again. And then swapping indices 3 and size minus 4. Sorry. I just now noticed it. Sorry, you must have been screaming at me through the screen. That's index 3, right? So we swap index 3 with size minus 4, which is 4 minus 4 is 0. And then watch what it's going to do. 4 and the 1, so 1 and the 4. Do you see how it puts it back to normal when you do it this many times? So that was too many swaps. We wanted to swap after just 2. All right, and so like we have to figure out how many swaps in general do we need for an array. So it looks like this is a size 4 array. It kind of makes sense that we want to swap half the size, right? 4 over 2 equals 2 swaps, right? We want to do 2 swaps here. And for the same reason, right? We don't really want to swap the 2 with itself. We don't need to. For v2, it's size 5. We also want to do, is 5 over 2 going to give us 2 again? We want 2 swaps, right? We want that many swaps. And actually, 5 over 2 is 2 if you use integer division. That's beautiful. So now you know it's always going to work. Now you know exactly how many times to play this game of swapping elements. Right? You always want to swap with integer division, size over 2 times. Right? Always size over 2 swaps. And that will correctly reverse whatever your array/vector is. That's a cool little algorithm that I think you discovered a little bit of, right? So I would like you to please try to code this up. Do your best, yell at me, ask me questions. I think that would make you a much better programmer. I think it's a really good practice. So try that, and that's where I want to stop today. All right, we'll come back and we will finish up arrays and vectors in the next lecture. So I will see you there.